Good morning, students. I am going to start the today's class. Today's topic is strain and different types of strains and moduli of velocity and their types. This is our topic. These topics are there in mechanical properties of solids. You listen very carefully. If you have any query, you write in the chat box. Okay, right. Going to start the class. In the last class, we discussed about the stresses and different types of stresses. Okay, stresses are three types: longitudinal stress, bulk stress, shear stress. Any stress formula is force by area. Okay, now I'm going to explain about the strain and their types. This is my topic. Then what is a strain? Strain means it is the ratio between change in dimension to the original dimension. The ratio between change in dimension to the original dimension. Hmm. The ratio between change in dimension to the original dimension is called as a strain. Dimension means what? Dimensions means length, area, volume. They are the dimensions: length, breadth, height. Okay. The ratio between the change in dimension to the original dimension is called as a strain. This is the formula for the. This is the definition for the strain. Okay. These strains are three types are there. Okay. These are these are three types. What are they? The first one is the longitudinal strain. Second one is the bulk strain. This bulk strain is also called as volume strain. And the third one is the shear strain. These are the three types of strains. Okay, right. Now let us we will discuss about these all things. Now, what is a strain? What I am telling? Strain means what? Strain is the it is the ratio between the change in dimension to the original dimension. Ratio between change in dimension to the original dimension. When dimension will changes, okay. If you apply the stress, stress means what? Force by area. Stress is the force by area. For example, this is a wire. On this wire, I am applying the force. Okay, this force by this area is called as a stress. Stress is the force applied on certain area. Force over force by area is called as the stress. Okay, this force by area is called as the stress. When you apply the stress, then it will be this wire may be elongate like this. That means it undergoes its length is increases now, right? its length is increases. That means this is called as a strain. Strain means the change in dimension. Its cross section is decreased. Its cross section initially A1, now finally it is A2. Now here you see when it is elongated, its length will be increases and its cross section will be decreases. This type of strain is called as oh, longitudinal strain. Okay, longitudinal strain. Actually, stress is also three types. When you apply the stress, then strain will occur. Stress means what? Stress is the force. When you apply the force by area, then at that moment strain will occur. Strain means what? Length changes, breadth changes, height changes, volume changes, area changes, shape changes, right? These all change in dimensions will occur due to the stress. That means when you apply the more stress, then more change in dimensions will occur. That change in dimension, the ratio between change in dimension to the original dimension is called as the strain. And stress is the force by area. When you apply the stress, then the object undergoes the strain. Okay, right? Stresses are three types are there: longitudinal, bulk, shear. And similarly strains also three types are there: longitudinal, bulk, and shear strain. Let us discuss about these all types of strains. The first one is what? Longitudinal strain. What is longitudinal strain and when it will occurs? Okay, in longitudinal strain, what will changes? Okay, that I am going to explain, and you listen very carefully. If you have any query while teaching, then you write in the chat box. Okay, what is longitudinal strain? Actually, strain formula is what? Strain formula is the change in dimension by original dimension. The strain is equal. Strain formula is change in dimension, change in dimension by original dimension. That is called as the strain. Strain not have any unit. It does not have any unit. Why it does not have any unit? Because the dimension is some, for example, you take it as length. Change in length by original length you will get. Meter by meter. That means meter by meter will cancel, then there is no unit for the strain. It does not have any unit. And no unit and no dimension for the strain. Let us discuss about the first type of strain. What is the first type of strain? That is a longitudinal strain. Longitudinal strain. It is the ratio between change in length. Here dimension is we have to take as length. The ratio between change in length to the original length is called as longitudinal strain. Longitudinal strain formula is change in length by original length. Change in length by original length. This is the formula for the longitudinal strain. Okay. Now this strain not have any unit and any dimension. Why? Because it is a change in length by original length. Length unit meter, original length unit also meter. Meter by meter, no unit. And no dimension also. Okay. Right. This is about longitudinal strain. Let us go for the next type of strain. And before that, I will give some example for this. Okay. Longitudinal strain example I am going to give. For example, you take a wire. This is a wire. Its original length is L. Now we are applying the stress like this. We are applying the force like this. Okay, the force is applied on this area A. That is nothing but stress we are applying it here. Now this is the original length. After applying the force and stress, the now the new wire length will be increased now. For example, this is the final length. Then the wire will become like this. Length is now L plus delta L. That means its length is increased. Its cross section is decreased. You see here. This cross section is A dash. Now this A dash new cross section is less than the original cross section. The original cross section is A. Okay. And here due to the stress, its length is increased here. Its dimension is changed. Length is changed. Now the longitudinal strain formula is longitudinal strain is equal to, we have tried to the change in dimension by original dimension, but the dimension is here length, that is delta L by L we can write, or otherwise sometimes we write EI by L also. E delta L means change in length. Original length is L, and delta L is the increase in length or change in length. This delta L we can also take as uh, change in length or the elongation also we can take. Okay, delta L is the change in length. Okay, or if you take the E is the delta L is also denoted with E. Okay, delta L or E both are same. This is the elongation. E is the elongation or compression. Okay, right. This is about change in longitudinal strain. Any doubt, students? If you have any query, write in the chat box. Is it clear till now, students? Is it appearing or not appearing? Students, is it clear? Write in the chat box. Do you have any query? Students, write in chat box. Okay, Anish, Alok, Jaya Boy Pai. Okay, very good. Now, I'm going to continue. Alok, any doubt? No, sir, you are telling. Okay, right. Next, I am going to explain about second type of strain. That is the bulk strain. Then, what is bulk strain? Bulk strain are the volume strain. In that test, volume will be changes. In that, volume will changes. Now, how volume will be changes? Let us see here. Okay, right. Now the next, let us discuss about the second type of strain. That is the bulk or the volume strain. What is bulk or volume strain? right? You see here, second type of strain I am going to explain. That is the bulk or volume strain. What is bulk or volume strain? Bulk or volume strain, it is its definition, it is the generally strain definition is what? It is the ratio between the change in dimension to the original dimension. Here we have to take the dimension volume. That's why we will get the definition like this. That is the ratio between change in volume to the original value. The ratio between change in volume to the original value is called as bulk or volume strain. Bulk or volume strain. Okay. The bulk strain formula is, it is the change in volume by original value. If length changes means that is a longitudinal strain. Okay. And volume changes means that is the bulk strain. This is the formula for the bulk strain. The bulk strain we can also write like this. We will take one example. For example, this is a ball. Okay. This ball has the original volume V. Now we applied the stress on this. We applied the force in all the directions like this, in the normal to this. For example, this is a ball. They are applying the stress like this. When you apply the stress, what happens? When you apply the stress on this, the ball volume will changes. Like this, I am applying the stress. Now the ball volume is decreased now. For example, this is the final volume. The final volume become V minus delta V. Right? That means the volume is decreased at here. Initial volume is V. Initial volume. Initial volume before applying the force is V. Now when you apply the force, the final volume is decreased. Now it is V minus delta V. What is the change in volume from the figure? Anyone write in the chart box? Bulk strain is equal to change in volume by original volume. What is the change in volume? Anshu Shavan, sir, what is E? Explain me. Change in length is only called as elongation. E means elongation. Elongation means change in length. When you will apply the force, previously I explained, na? Just this is a wire. It has L original length. If you apply the force on this wire, it is elongated. Now the new length will become L plus delta L, or otherwise we can also take it as L plus E. This E is called as elongation. That means instead of delta L, we can also denote with E. That means the strain formula, longitudinal strain formula, we write as delta L by L. Instead of delta L, we can also denote with E. I am telling. Delta L is also change in length. E is also change in length. Change in length means how much elongation is occurred. That is the change in length. Elongation means what? Increase in length. For example, this is the original length. Okay. Now when you apply the force on this, now it is elongated. This is L plus E after elongation. Now this will become, this is the original length and this is the elongation. This elongation is the increase in length. This is also denoted with delta L. Delta L we can also write as E. Okay, delta L we can also write as E. Delta L or E both are same. Okay, delta L means change in length or elongation. E also change in length or elongation. Both are same. Okay, but only the letter is changed. Instead of delta L, we can also use E. That is the thing. Okay, right. Now we are discussing. Is it clear? Anshu Savyan. Sorry, Anish Kumar. Anshu Savyan is asking, na? Right. Bulk strain is the change in volume. What is the change in volume in this figure? Initial volume is V. Final volume is V minus delta V. change in volume is minus delta V. Change in volume is minus delta V by original volume is V. Original volume means initial volume. This is the formula for the bulk strain. Bulk strain is the change in volume by original volume. Okay, right. It is also not have any unit because volume by volume. Okay, in the numerator change in value. This what minus sign indicates at here. The negative sign indicates decrease in volume. Negative sign indicates decrease in volume. Decrease in volume. Okay, right. This is about the bulk strain. Now it also not have any dimensions. When this bulk strain will be occurs generally, for example, you are have a rubber ball. Okay, if your rubber ball dip in the water, okay, for example, this is a rubber ball. Okay, when we dip the rubber ball in the water, then what happens? Water applies the force on the rubber ball in all the directions. That is called as the hydraulic pressure. Water pressure is called as the liquid pressure is called as the hydraulic pressure. Due to the water pressure, what happens? Its initial volume is V, but after dropping in the water, after when we immerse this rubber ball in the water, due to the water pressure, its volume is decreased. The final volume is V minus delta V. This type of change in volume is occurred due to the hydraulic pressure or hydraulic stress, liquid pressure. Okay, this type of strain is called as the bulk or volume strain. Now let us go for the next one. That is the third one. Third one is called as the shear strain. What is the shear or shear strain? Okay, when you apply the bulk stress, when you will apply the bulk stress, bulk strain will occurs. When you apply the bulk stress, bulk strain will occurs. When you apply the longitudinal stress, longitudinal strain will occurs. Right? Now let us go for the next one. Third one. What is the third one? Third one is the shear strain. What is shear strain? Shear strain means I will tell the shear strain definition. Okay, it is somewhat different. It will be there. When you apply the shear stress, it will happens. For example, this is a rigid support, and this is a rectangular object, rectangular object. And now on this object, what we are doing it here. For example, it is a cuboid. Okay, and now we are applying the force parallel to the surface. Okay, the lower surface is fixed at here. The lower face is fixed, and the upper face we are applying the force at here. The force is applied parallel to the surface like this. We are applying the force. When you apply by fixing the lower face, if you apply the force on the upper surface, then what happens? Okay, the we are fixing the lower surface. Lower surface is fixed. Lower surface is fixed. Okay, on the upper surface, we are applying the force. This force is parallel to the surface, and the force is applied on certain area. This force by area is called as the shear stress. Shear stress means if any stress applied parallel to the surface, okay, parallel to the surface, that is called as the shear stress. And now it will be bends like this. Okay, then it will become like this. the upper face displaces, okay, and by some angle, this angle we can take as theta. This is the theta through which it will angle through which it is rotated, tilted. The upper face is tilted at here, okay, upper face is displaced to a side, its shape is changed now, okay, and the displacement of the upper face we can take as delta x. This is the delta x at here. This is the displacement of the upper face. Upper face displacement is delta x, and the perpendicular distance between the two layers we can take as upper layer is, this one is the upper layer and this is the lower layer, right? The perpendicular distance between the two layers is L. And now the shear strain definition is, comparing with the lower layer, the upper layer is displaced by some distance, that is a delta x, because of tangential force, and the ratio between relative displacement of upper layer comparing with lower layer, relative displacement of upper layer to the perpendicular distance between two layers, perpendicular distance between two layers, perpendicular distance between two layers is called as shear strain. This is about shear strain. The formula for the shear strain is equal to relative displacement of upper layer. From the figure, what is the displacement of upper layer? Upper layer displacement is delta x. What we are doing it here, this is a cuboid, the lower face is fixed to the rigid support, and on the upper face we are applying the force parallel to the surface of upper surface. Due to the upper surface is displaced but lower surface does not move because lower surface is fixed, and then it takes some displacement. Comparing with the lower layer, upper layer is displaced by some distance, that is called as relative displacement, that is delta x, and the perpendicular distance between the two layers, this is the upper layer and this is the lower layer. The perpendicular distance between the two layers is L, that is delta x by L is the formula for the shear strain. This is about shear strain, and it is also not have any unit, no unit, and no dimensions. Okay, right. And the next one is, this is shear strain, we can also write like this, just we can write it as just like angle only. Okay, shear strain we can write as theta. Why we can write theta? Theta is, if it is shear strain is very small, theta we can write as tan theta. The tan theta what we can write, opposite side by adjacent side we can write. That means shear strain we can also write as theta, that is equal to delta x by L. Okay, understood students? Any doubt? This is about strain and different types of strains. Write in the chat box, students. Okay. Next, let us go for the one more topic, that is the Hooke's law. What is Hooke's law? Hooke is the name of the scientist. He gave some relation between the stress and strain. That relation I am going to explain now. Next topic is the Hooke's law. What is Hooke's law? Hooke's law is that, right? Very simple it is. That is, okay, Jaya, good. If you have any query, write in the chat box. Hooke's law. Hooke's law is that stress is directly proportional to the stress is directly proportional to the stress is directly proportional to the strain. This is called as Hooke's law. Stress is directly proportional to strain is called as Hooke's law. Okay, this is Hooke's law. Hooke's law means stress proportional to strain. Very simple it is. Stress proportional to strain. Okay, when you apply the more stress, then more strain occurs, right? And when the proportionality is removed, we will get a constant. That constant name is capital E, denoted with capital E. Its name is modulus of elasticity. Okay, right. If you apply more mental stress, then mental strain will occur. If you apply the physical stress, the physical strain will occur. Stress means force you are applying. When you apply the force, then the change in length, area, volume will occur. Shape changes. That is called as the strain. When you apply the force, the strains will changes, length will changes, dimensions will changes. Right? That is called as a strain. When you apply more stress, then more strain occurs. The stress and strain are proportional to each other. When the proportionality is removed, we will get a constant. That constant name is moduli of velocity or the modulus of velocity, we can tell. It is called as modulus of elasticity. Modulus of elasticity. Okay, right. Now we will go for the modulus of velocity. What is modulus of velocity and on what factors it depends? Okay, right. Modulus of elasticity means it is the ratio between shear stress to the strain. Okay, the ratio between stress to the strain is called as modulus of velocity. Modulus of velocity is the ratio between stress and strain. Modulus of velocity denoted with E. Modulus of velocity formula is stress by strain. Okay, right. Now, what is the unit of the modulus of velocity? What is the unit of the modulus of velocity? Anyone can write the unit of the modulus of velocity. What is the unit of the modulus of velocity? Modulus of velocity, modulus of elasticity depends upon nature of material. It depends upon nature of material. Different materials have the different modulus of velocity. Okay, and its unit of E. What is the unit of E? Can anyone write? Unit of stress unit is the stress is the force by area. Strain is the strain not have any unit. Then force stress unit only modulus of velocity unit. That means Newton per meter square. Force by area. Newton per meter square is the unit. Can you write the dimensions? What is the dimension set here? Dimension formula is what? Dimension formula. Dimension formula for E. Right? Dimension formula is very simple. Stress dimension formula is what? Force by area. Force ka dimension formula is what? MA. MLT power minus 2. Force by area is length into breadth L square. Then ML inverse T power minus 2. It is the dimension formula of modulus of velocity. And the modulus of velocities are three types are there. Why modulus of velocities are three types are there? Because we know that We know that the stresses are three types, strains are three types. You see here, stresses are three types, corresponding strains are three types. That's why modulus of velocity is also three types. Let us discuss about them. Now, first one, mod. These are means modulus of velocity, moduli of velocity. These are three types. What are they? First one is Young's modulus. Young's modulus. Second one is the shear, sorry, bulk modulus. Bulk modulus. Young's modulus denoted with Y. Bulk modulus denoted with B. Third one is the shear or rigidity modulus. Rigidity modulus. That is eta. Okay, these are the three types of modulus. Okay, Young's modulus, bulk modulus, and shear modulus. Let us discuss about the first one. Okay, after completion of these three moduli, then I will close today's lecture. Okay, right. More 20 minutes I will take the class. First one is the Young's modulus. What is Young's modulus? Young's modulus is the Y. It is the ratio between any modulus, it is the ratio between the stress and strain. Okay, ratio between longitudinal stress, the ratio between longitudinal stress to the longitudinal strain is called as Young's modulus. Young's modulus. Young's modulus formula is longitudinal stress by longitudinal stress. If you apply the longitudinal stress, then which dimension changes? Length changes. Length changes means that strain is called as a longitudinal strain. If you apply the longitudinal stress, then the longitudinal strain will occur. Then what is the formula for the longitudinal stress? Force by area, any stress formula. Longitudinal strain formula is what? Delta L by L, or sometimes E by L also we can write. Okay. Then we can write like this. Young's modulus formula we can write like this: FL by A delta L we write, because this will become like this: F by A into this delta L by L will be reverse, it will become L by delta L. This is the formula for the Young's modulus. Okay, this formula we can also write like this: Y is equal to FL by EY AE also we can write. Why we write AE instead of delta L? We can take also E also, na? That's why we can write E also. This in this formula, what is F? F is the force that tries to elongate a wire. For example, this is a rigid support. We are hanging some wire at here, and when you apply the stress at here, if you apply the stress like this, if you apply the force on this area, then it will be elongated. The wire will be elongated. For example, the wire length is increased at here. The wire original length is L and increase in length is E. Okay, that means L is what? F is the force we are applying to elongate it, right? This is the deformation force. We can also write as deformation force, but it will try to change the length, or the restoring force. L is what it here? L is the original length. L is the original length. What is E? E is the elongation. E is the elongation. A is what? A is the pi r square, we can write. That is the area of cross section. Area of cross section of wire. What is E or delta L? Both are same actually. Remember it. E or delta L. Okay. Right. That is elongation or change in length. Elongation or change in length, right? Okay, this is about Young's modulus, and what is the need of to define this Young's modulus, and I'm going to explain some more information regarding the Young's modulus. You listen very carefully. If you have any query, you write in the chat box. Okay, here we got the Young's modulus formula. Y is equal to FL by AE. Okay, you know terms also. What is it? What is the need to define the Young's modulus? On what factors the Young's modulus depends? Young's modulus depends upon Young's modulus depends upon nature of material. That means different materials having the different Young's modulus. Nature of material, but independent of its dimensions. Okay, but independent of its dimensions. Okay, right. And this is about Young's modulus. And what is the need to define the Young's modulus? If you come, this Young's modulus is defined for the Y is defined for solids. Young's modulus is defined for the solids only. Okay, it's a change in length. Change in length is occurred for the solids only. And this Young's modulus, we got formula stress by strain. Okay, if strain is less, the materials which have less strain, okay, they have more Young's modulus. More Young's modulus, because Young's modulus basic formula is stress by strain, longitudinal stress by longitudinal strain. Okay, if strain is less, then Young's modulus is more. Young's modulus is more. Okay, right. For example, if you take the different types of aluminum among some substances, I will write aluminum, copper, iron, steel. Okay, okay. Among aluminum, copper, iron, steel, the steel has large Young modulus. Large Young's modulus. It has more Young's modulus means it is more elastic. Its strain is less, because Young's modulus formula is what? Young's modulus formula, you know, stress by strain. Young's modulus formula is stress by strain. That means Y. For example, you see here, if elongation is Y is equal to FL by AE is the formula, or Y is equal to FL by A delta L is the formula. If delta L is less, change in length is less. Okay, then Young's modulus is more. That means if Young's modulus is more, the change in length is less. right? That means we say that the change in length is less means it is more elastic. Okay, it will always uh, stay its original shape and size. That's why its change in length is less. The material which have more Young's modulus, its strain is less. Okay, if y is more, delta L is less because they are inversely proportional, right? The material steel is more elastic than rubber or aluminum or copper. Okay, because its Young's modulus is more. Its Young's modulus is more and strain is less. Change in length is less. It does not have any change in length. That's why steel is more elastic than rubber, and the steel is more strong. Why the steel is more strong comparing with the aluminum, copper, wire, aluminum, copper, and some other substances? Comparing with the others, right? Comparing with the aluminum, copper, and other materials, okay, the steel is strong. Why the steel is strong? Because the steel Young's modulus is more. Steel Young's modulus is more means the strain is less. Strain is less means change in length is less. Change in length is less means it does not deform easily. Its shape does not changes easily. Okay, its length, volume, area also does not changes easily, and its its stiffness is more. Okay, it is very strong. That's why even we to make the heavy duty machines very strong, if you want to make any machine very strong, then you should use the steel material because steel is more elastic than other materials. Okay, right. Now let us go for the next one. The second type is what? Bulk modulus, right? Second type is what? Bulk modulus. Bulk modulus. Bulk modulus is denoted with K, sorry, B or K, sometimes B, sometimes K also. Okay, right. Bulk modulus definition is what? It is the ratio between volume stress to the volume strain. The ratio between volume stress to the volume strain is called as bulk modulus. Okay, bulk modulus. The bulk modulus formula is bulk modulus formula is volume stress by volume strain. Its formula is volume stress by volume strain. Okay, right. What is the volume stress? Okay, for example, this is a rubber ball. Its volume is V. Initial volume is V. Now, if it is dip in the liquid, if we dip the ball in the liquid, what happens? Certain depth up to h depth, if we dip, then its volume is decreased. The final volume we can take as V minus delta V. Okay, why the ball volume is decreased at here? Because of the pressure, right? This the liquid applies the pressure. The pressure, this force by area is called as the pressure. The pressure at a depth h formula we know, right? We can derive in the next class also. That is a rho gh. Okay, the bulk modulus we can also write as like this: volume stress. Volume stress is also called as hydraulic stress, liquid stress, that is equal to pressure. Hydraulic stress, hydraulic stress or the pressure we can write. Okay, by volume strain. Volume strain is what? Change in volume by original volume minus delta v by v we can write. Then b formula we can write as minus pv by delta v we can write. This is the formula for the bulk modulus. Okay, this is the formula for the bulk modulus, where p is the pressure. P is the pressure. Okay, you remember that the pressure formula at a depth h formula is rho gh. Okay, pressure formula is rho gh, and the rho is the density of the liquid. Rho is the density of liquid. G is the acceleration due to gravity. Acceleration due to gravity. And delta V is the change in volume. Change in volume. Okay, the B is defined for the bulk modulus. Here negative sign what indicates? Again the decrease in volume. Negative sign indicates the decrease in volume. Okay, this bulk modulus defined for solid, liquid, and gases also. Okay, this is about bulk modulus. This is also not have what happens, its unit is what? Any modulus have the same unit, that is stress by area, stress by strain. Stress unit is Newton per meter square, force by area. Strain not have any unit. This is about bulk modulus. Now in the bulk modulus there is a little definition is also there. Compressibility I am going to explain next. Compressibility. What is compressibility? Compressibility, it is the ratio, reciprocal of bulk modulus. Reciprocal of bulk modulus is called as the compressibility. More 5 minutes I will continue. Next one is what? Compressibility. Okay, compressibility. Compressibility is K. It is the reciprocal of bulk modulus. The of reciprocal of bulk modulus is called as compressibility. Compressibility formula is 1 by bulk modulus. Is the formula for the compressibility. That is C. This we can also write as K. K is the bulk modulus. That is the 1 by B. Its formula is, okay. Previously we discussed about the B formula, right? Its reciprocal is the compressibility. Okay. 1 by bulk modulus. That is minus delta V by PV. Next, third type of modulus. It is the last one. After this, I will close. That is shear or rigidity modulus. Shear or rigidity modulus. What is shear or rigidity modulus? It is the ratio between shear stress to the shear strain is called as rigidity modulus. Rigidity modulus. Its formula is rigidity modulus is equal to rigidity modulus is equal to shear stress by shear strain. Its formula is shear stress formula is what? F by A. Shear strain formula we discussed previously, theta. F by A theta. Okay, this is the formula, or otherwise theta we can also write as delta x by L. Like this we can write. This is the formula for the shear rigidity modulus. This we know already. For example, this is a rectangular body. If you apply the tangential force at here, it the upper face will be displaces like this, and this is the displacement, and this is the perpendicular distance. This is the angle, and now this force is applied on certain area. That area is called as force by that area is called as a stress. Okay, and now this is the angle through which it is rotated. Now no unit. Sorry. It's unit. What is the unit of this one? Stress by strain. Strain not have any unit. Stress unit only the same. That is unit is Newton per meter square. Okay, right. And remaining we will discuss next class. I'm going to close. Thank you. Thank you to all.